Thank you for joining us today. For those of you who don't know us, we're Jingdiao North America. Our parent company, Beijing Jingdiao, has been in business for 20 years. It got its start as a CNC control manufacturer developed by our founder, who is a computer scientist. Saw a need for this type of technology to help grow the economy in China, and has invested a lot of money in R&D. Took it from there to machine tool applications, and has further evolved it to where we are today. Some of the things we're going to be talking about is mold making. Obviously, we're here at the mold making trade show, but also we want to talk about the technology that goes into it, because the technology can be used in a lot of different applications. So I think the title of this is Online Measurement. And the way we look at this is not just the measurement, it is going to be an entire process. We talk about seamless fit. We talk about, the old world masters that are doing the final fitting to get to a bearing surface. But that presents problems in terms of repeatable accuracy. Final fits is not always guaranteed. And what we do throughout our process, starting with a CAD/CAM system of our design, machine technology of our design, as well as how we apply that, is we're making it a one-time setup from a specific data set so that it can be replicated on a regular basis. So what we have is a 5-axis machining center that we're simulating a twisted part. Basically, we're working from a master data set that we're going to go ahead and measure the part. Once we've done the basic machining, we take it to semi-finish. And then from there, you can see right on the machine, once we go ahead and plot it, we're looking for high spots and low spots. Once we have assembled all that data, we do a comparison, and then we'll do the final finish cut. So from there, we'll have a perfect match between the two mating parts. Now, those of you who make molds for your customers, there's always a tradition that we make both sets at the same time. But we also know that there's one wear component. So your customer, if he has a wear component's going bad, you're forced to make another set. With this type of technology is with that data set that's already been built as a master. Let's say you build a two-part mold for your customer. The wear component could also be made. So you deliver it to your customer, it's called Joe. Joe, here's your finished product. By the way, I have your wear component. Why don't you put it up on your shelf? When you use it, let me know, and I'll make another one for you. So it's that type of finish that we're able to do repeatedly with or without a match set. Seamless, based on the fact that we were able to measure these data points, we're able to achieve the seamless fits. And we'll go into some samples here to demonstrate just that. But on a 5-axis machine of this type, we're also able to achieve mirror finishes coming right off the machine. And all the technology I'm talking about is developed by Jingdiao. The CAD/CAM system, we have a solid model plug-in. The ability to run the routines, not just for cutting path, but also for the probing cycles. We use a standard Renishaw OMP 400, which is the most accurate one that they have for machine tool applications. But we don't use their interface. It's our own code, our own interface that we use. And during IMTS, we had Renishaw come into the booth, and it was quite rewarding because they looked at it and said, we can't do that, based on the types of tolerance that we're having. With the 5-axis machine, we're able to achieve those mirror finishes I mentioned. Typically in a 3-axis application, someone who's familiar with a tooling, the materials, coolant, to get a mirror finish in a 3-axis is relatively achievable. But to do it in a 5-axis, where you have entered in 2 rotary axes, which we mechanical engineers know is always going to be the weakest point and do it simultaneous with your 3 linear axes, we're able to achieve that mirror finish. You would think polished, but it comes off the machine just that way. So when you think about the different applications and the amount of time from a manual labor standpoint to achieve those same finishes, it's costly. And that's what we're trying to do in terms of supplying a product, supply a solution that eliminates that necessity. Same thing with the match mold sets. When they come off the machine, there's no requirement for deburr, there's no requirement for bench work, there's no requirement theoretically for measurement, because it's all been qualified on the machine from your set of master data. Some of the technologies that are built in the machine are our own control. That gives us a lot of capability rather than using some of the traditional brands that we're all familiar with. DDM motors of our own design. Feedback, the rotary feedback. There's some names that we're all familiar with, but we work with them to develop a spec that works for our particular application in our machine as well. So you're going to see some accuracies that are very impressive. Additionally, the machine is stable, it is repeatable to the point where we can demonstrate 1 to 14 diameter to length ratio on cutting tools. So for example, in the molds where we have that deep pocket that we need to get into, that we always relied on someone to do the final blending, we can reach those very deep pockets. Again, it goes back to the spindle design is our own, so we eliminate radial play, Z-axis extension, and it is repeatable. Some of the applications that we do for customers, working on one for a U.S. manufacturer right now that to guarantee a particular location or a particular height, we'll go ahead and probe it. In some cases, orientation is critical, so we use a CCD system to look at the orientation, and then we'll make adjustments to the machine offsets to automatically follow through with that. On that particular part, we are holding a depth of plus or minus 10 micron, but we have a capability of 133 CPK with a 167 PPK, and we're holding in our shop, which is environmentally controlled, less than plus or minus 2 micron. So when you think about it, plus or minus 2 micron, holding a depth all day long, this is where our advantage is as compared to doing the final fit that you might have to do on your current process or current equipment. So based on these types of technologies, and again, you can see how we're plotting the data, where we are looking for those highs and lows, doing the comparison, and then we'll do the final cut. Once we're concluded, we invite you to take a look at all these parts, feel the finish, feel the fit, and kind of get a feel for what we're just doing on the machining side. Now let's take it one step further. We talk about application. For die mold, there's a lot more to it. Grinding, for example, jig grinding. Some of the other things that go into it. Also very capable on this machine. We built the machine with a specific application in mind, and you will see that in our entire product line. But what we're representing here is targeted to those who are attending the show that are master, right? You're all masters at building die molds. With that, again, look at the parts, look at what we call seamless. Again, it all goes to a complete process, a complete application. It's not just one special tool. It's not a piece of software. It's an entire process, and this is what we deliver to our customers. So with that, I would like to pass it on to Jason, who's going to walk you through quickly our CAD/CAM system, so you get an idea of where the entire process starts. So this is a key component in terms of building the program, the tool paths, the correct tools, and parameters to achieve some of these results we're talking about.
Okay, thanks, Hans. So for 5-axis machining, the movement of the machine is too complicated, and machining process is non-virtual and difficult to predict the risk of the collision. So in Jingdiao virtual processing technology, we construct the virtual model in CAM software. We can simulate the programming and detect and eliminate the collision in programming phase, make 5-axis programming safer. So let us give you a basic introduction about our CAM software. So this one is our GD software, SurfMill 9.0. So as you can see from here, it's a rainbow toolbar on the top, and it's about intersurface on the left. You can change the different status of working, the scratch, the surface, the toolbars, and right-click on the top. You can choose what window you need, like the layer, like the object property, like layer. So basically, what I want to know is about the simulation function in our CAM software. After you programming the toolbars in the 5-axis machining, the difficulty is about you don't know this program is safe or not. So in Jingdiao machining process, we can choose about the entire process in here. You can choose right-click here to choose about gate check and collision check. Okay, sorry. Okay. The two parts go check and begin. Okay. It seems no gate two parts. Then use the hold the collision check. Also, he calculated about the result of the two lengths, what you need. So after finish that, we can choose about the machine simulation here. Right click here, the machine simulation. You can based on what kind of machine you need. You can modify the machine simulation here and then simulate the two parts. Before that, you can see in here, the yellow here is orange, not green. It means the overcar is safe, the collision is safe, but simulation unknown. So let us go to the machine simulation. Okay, let us do it. So make it vertical, I need to do something about the machine construction. Hi, this one. Okay. Here we go. Let's speed up. So the entire processing is directly run on your computer. So the NC code, the G code runs around on the left. It will have collision. It will allow me to know you the two parts is not safe. But now I just choose the right two parts. Speed up. It will take a few seconds. Okay. So this is 100% just like what we machining on our machine, you know. So A few seconds. Okay, finish. Then no anomaly on the intersurface. So then we click OK, and it will show in here the yellow turn orange to green, right? So we can make sure that this toolpath is safe. So unlike this one, this is the original toolpath I made. I made the gate check. Hold gate check. So it alarm is in here. So the red one is unsafe. So when we output the NC code, it will alarm me and don't allow you to out these two parts. So this is basic introduction about our KCAM software. It's called SurfMill 9.0. Okay.
One of the things that I had talked about was the different applications. Here again, we're talking about die mold, machining in H13, hardened materials. But to kind of give you an idea in terms of not just selling a machine and selling a process and a solution, this is a part I think is pretty well known. We see it all over the United States. I see a lot of them in the western side of Michigan. This particular customer came to us with a cycle time of 18 minutes. I see 14, 16 out there, but the goal he gave us, the target was 10 minutes. So based on our development, working with the customer and a little Jingdiao magic, we got it down to almost 7 minutes. Now we continue to work with the customer, and now he's down to 4 minutes. So the reason I'm sharing this with you is we do that in all the work that we do. We're looking to establish a collaborative type of relationship, working together to understand what your needs are, what the problems are that you've had with the parts, or possibly quoting a new job that we would advise and possibly even cut a part or sample part for you to demonstrate a good process, a good application, and how it would apply. People will look at this being aluminum thinking it's real simple. But when you think about what it takes, Op 20, okay, the easy part is Op 10 where we're turning the geometry to go from 18 minutes down to 4 minutes on our machine, I think it's pretty impressive. And you'll find that in some of our other applications as well. So again, we're not here to sell the machine, we're here to sell the solution. Here's a perfect example. This customer, we could have sold multiple more machines. That's not what we're all about. Able to bring him something that exceeded his expectations, but bottom line is he's able to now make a lot of money based on the short time he spent with us. So again, that's the kind of relationship that we've developed with our customers. So far here in the U.S., customers we've developed, we enjoy that. It's a collaborative effort, nothing to hide. We all have the same common goal. And with customers' know-how and our know-how, we achieve these types of results.
My name is PJ Naughton. I'm the sales manager for Jingdiao. When I first started at Jingdiao here, I noticed that there was a video that went viral on the internet. It was a video of our sample parts. Usually when you think of video going viral, you think 1, 2, maybe 3 million views. Our video went viral with 18 million views on the internet. It was on YouTube. I think it had 100,000 retweets. It even made it to the first page of Reddit. So what we're going to do here is we're going to demonstrate some of these high precision samples that came off of the Jingdiao machine. Charles, can you give me a hand here? I tell you what, Charles, let's start off with the spiral fit there. And please explain this part.
Okay, so this part is actually consisted with could you consist with two parts. One is a core, and one is a cavity, and both of these two parts are finished on our 5-axis machine right here. So the clearance between these two parts is within 2 micron because of our high precision machining capability and good control of the environment. So with the 2 micron clearance, the air seal is so good that it can lift up a weight underside with a flat surface easily. Yeah, and
But wait, there's more. All right, we're going to take that part and we're going to put it on steroids right here. Over here, we have a block that's close to 50 pounds. So go ahead, and what we're going to do is we're going to crank up on this device here, and there's a spiral punch, the same one that you see here. But it's got the air suction here is so tight, it's only a 2 micron clearance between the punch and the die. It's going to create air suction and pick up a 50-pound block. Give it a couple of cranks there. Now, if you can, zoom in to the punch section right there. You're going to see it slowly drip out there. That's because of the 2 micron difference between the punch and the die. So the fit is so tight, it would take over 3 minutes for this part to finally drop out. This is not something I've ever seen before. Okay. All right, let's bring it down. Okay. You want to show them the punch? So that finish actually came off of the machine. It was not hand polished. Another one of the blocks that went viral on our video is this part. So this part is actually 2 parts that were machined on the Jingdiao. If you zoom in there, it's almost impossible to see the parting line between the 2 parts there. But go ahead, pull it apart. And let's take it apart again. Let's show them the finish on the part. Once again, it looked like it was hand finished. Pardon me, hand polished. It actually came off of the machine with that finish. Let's show them this example, and let's take the part apart. And we're going to rotate it in 4 different directions there, and it still fits perfectly. So also with these parts, they've been machined on different machining centers, but they're also interchangeable, which means we could take one part, switch it with the other, and it's still going to be a perfect part. And if you zoom in there, you can see the parting lines are almost invisible. So that shows how well built the Jingdiao machines are, that you could even switch parts from machine to machine and come out with the same results. You want to do this one next? Okay. So on this part here, it was milled and ground, correct?
Yeah.
Okay, so we have 5 minutes? Okay, so we got 13 holes here, okay? In 3 different plates. We're gonna remove the pins, and then we're gonna rotate the plates.
So I just want to add something here. Those 3 plates, all the holes are made independently for each layer of the plates. So totally it's 39 holes and fitting together.
We'll leave the center pin in so it could rotate. So if this is a dead nuts accurate part, all those pins are going to fit right in there before we rotated the part. The first pin is in.
So the whole position is dimension, whole position accuracy 2 microns.
So the whole position is within 2 microns.
And the fitting clearance also 2 microns.
And the fitting clearance is also 2 microns. All right, we're in the home stretch. We got 3 pins left. $12. And 13 pins. It's a perfect fit on a Jingdiao machine. We got one more sample to show you. Okay, we're going to wrap it up here. We're going to go with this large fit. Charles is going to pull this piece apart. Go ahead. Well, you got a problem here? You can't do it? Come on. Wendy, push him out of the way.
Maybe it's time to show the girl like Wonder Lady in Jingdiao. See what I can do, like a little girl like as me. Superpower and
Well,
easy peasy.
let's give Wendy a round of applause there. Thank you so much for standing by and watching our presentation, and we invite anybody to come in our booth and learn more about our products. Thank you so much. Have a good day.